The new topic that we start with now is stereometry, which means geometry in space or just the geometry of solids. Solid is in German ein Körper. As a start, let us look at some basic formulae from planimetry, and I'll let you complete the script by your own based on what you see here. We see then also as a second part the circle. The formula for the circle should be clear, and also for the segment of a circle, the one that you should be most aware, which we will most probably use most, is that the area of a segment can be calculated as A times R divided by 2, A being the length of the arc and R the radius of the circle. Now let us look at the surface area of different solids. The cuboid and the cube should be self-explanatory, so you can copy it from here. Let's go to prisms. The total surface consists of the base face and the top face, and then of the lateral face, where the lateral face in German is Mantelfläche, and I use also the M for the lateral face, therefore. I think that the formula again is self-explanatory. What we see is that in the end we can describe the surface as 2 times the base face area plus the perimeter of the base face times the height of the prism. And you see that we noted exactly this formula also as one for the cuboid. Well, the cuboid is just a prism, a right prism with rectangular base. Next, let's look at the cylinder. Its surface consists of base face and top face, and again of the lateral face M. When we cut the lateral face perpendicularly to the base face, we cut it open here and we unfold it, what we get is a rectangle with one side length being the height of the cylinder and the other side length being the circumference of the base circle. So the lateral face is 2 pi times r times h, and we get for the surface of the cylinder just 2 times the pi r squared, the base and the top face, plus the 2 pi r h, the lateral face. A right cone is obtained by connecting a circle with a point vertically above the center of the circle. The surface consists of the base face and the lateral face. When we cut the lateral face open along a slant edge, what we get is a segment of a circle, and the radius of this segment corresponds to the length of the slant edge, and the arc length of the segment corresponds exactly to the circumference of the base circle of the cone. When revising the formula for planimetry, we have seen that the area of such a segment is obtained as the product S times this length of the arc divided by 2. So we end up with pi r s, and we get for the total surface pi r squared, the base face, plus pi r s, the lateral face. Since the slant edge, the radius of the base face and the height of the pyramid form a right-angled triangle, Pythagoras holds for their relationship. Here we look at a pyramid with a square as a base face, and we see that the surface consists of the base face square and of 4 identical triangles. So we have to find the area of the triangles, which is shown here. And we get the general formula for the surface of a pyramid, which is just base face plus lateral face, and inserting in this special case the base face and what we found for the lateral face, we find this formula here. For oblique prisms and cylinders, The volume can be calculated the same way as for right prisms and cylinders, namely as the base phase times the height. We can see that when we look at the beer mat model. The volume of pyramids and cones here is just provided as a formula without reasoning. We'll see the proof later. Maybe it is helpful to remember it that for the area of a triangle, we take base side length times altitude divided by 2. We are in 2 dimensions. For a cone or a pyramid, which is also something with a apex and a spitze, we are now in 3 dimensions. So we take g times h divided by 3 dimensions. Here in example 2 for the oblique prism, note that for calculating the surface, the lateral sides of the prism are not the same ones. This here is a parallelogram, as drawn here, while this side here is a rectangle